Welcome back. We are studying ellipses in this video series. In this video, we're going to look at the eccentricity of an ellipse. That measures how stretched out the ellipse is. So the eccentricity, we call it E. We define it as the ratio of C to A, where C is the x-coordinate of the foci, either positive c to the right or negative c to the left, for an ellipse centered at the origin. C is the distance from the center to the focus anyways, regardless of where it's centered. And A is the distance from the center to either vertex. So because the vertices are always past the foci, in other words, the focus is inside every ellipse, C always has to be less than A, and therefore, and it can't be negative either, right? C is the distance from 0 to a focus. So C is somewhere between 0 and A. So if C is equal to 0, the eccentricity is 0, and your foci are at the center, in which case you have a circle. Or if C is all the way really out here, very close to A, you would have a number very close to 1, in which case you would have a super duper stretched ellipse like that. So it just measures how stretched out it is as a number between 0 and 1, 0 being more like a circle, 1 being a really stretched out ellipse. So what we're going to do is we're going to find the equation of the ellipse with foci at 0, plus or minus 8, and eccentricity equal to 4/5. So we just learned that eccentricity is the ratio of C to A, where C is the distance from a focus to the center and A is the distance from a vertex to the center. So if you plot these points, 0, plus or minus 8, you quickly realize, right, that those are on the y-axis. 0, 8 is up here, 0, -8 is down here. And that's a way of telling us C, because C is the distance from the center to a focus. So C is 8. So we can substitute that value in right here for C to get 8 over A is equal to 4/5. And maybe you cross multiply, or maybe you realize that 4 times 2 is 8, so therefore 5 times 2 is 10. And so therefore A is going to equal 10. That's the vertex. It would be up here just a little bit past those foci. So if A is 10, we know C is 8. We still need B in order to find the equation of this ellipse. But for that, we can use this relationship between A, B, and C, which we derived earlier, which is that C squared is equal to A squared minus B squared. And we can use that to solve for B squared. C is 8. So if we substitute that in there, we have 8 squared equals to A is 10. Right, so 8 squared is 64. So 64 is equal to 100 minus B squared. So if we add B squared to both sides just to make it positive, put it on the other side and get it on the left, we'll have B squared is equal to, and I'm going to subtract 64 from both sides. 100 minus 64 is 36. So therefore B is equal to the square root of 36, or 6. That's the distance from the center to the endpoint of the minor axis, right? And that's all the information that we need in order to write the equation of this ellipse in standard form. So since A is larger, and we know A is vertical, it's going to go under the y squared, and the B squared, let's just write out the general formula first. The B squared is going to go under the x squared. So y squared over B squared, I'm sorry, x squared over B squared plus y squared over A squared is equal to 1. And so if we then plug in, okay, B is 6. If we square 6, we're going to have 36. So x squared plus 36 plus y squared over A squared. A is 10, so A squared is 100 is equal to 1. And we have the standard equation of this ellipse.